Welcome to Spring LIB.
Okay, this problem is asking us to propose a mechanism for the synthesis starting from caprolactam and ending up with nylon 6. Okay, so we start off with our caprolactam, which is a 7-membered ring in which we have a lactam. So a lactam is just an amide in a cyclic form. So here's my caprolactam, and it is stated that water is going to help synthesize an open chain amino acid. So my water is going to come in and attack that carbonyl. Okay, when it attacks that carbonyl, the electrons from that double bond are going to come up to my oxygen. Okay, now I form this tetrahedral intermediate, in which I have my nitrogen here, unaffected, and then I have my remainder of my compound, where I have my oxygen with a negative charge, and then the water that I just had come in right here, and that has a positive charge. Okay, so normally within organic chemistry, we see if we have a negative charge and a positive charge within the same molecule, we undergo a proton transfer if the mechanism is calling for it. But in this case, because if I were to have the oxygen get protonated by my hydrogen, it would just not make sense in the further steps of my mechanism, because I'm eventually going to want to make this nitrogen leave as a leaving group. Okay, so what is going to happen is, and this is just a step that would make sense, is my electrons on my oxygen are going to come down, forming a double bond onto this single bond. When that happens, this carbon has exceeded its octet, so it needs to have a leaving group. Okay, so this nitrogen, I would want to make it leave, but if that leaves, that would have a negative charge, and this oxygen would still have a positive charge. So instead, I'm going to depict that arrow going and attacking my hydrogen, and then the electrons from that single bond between the hydrogen and the oxygen are going to go on to that oxygen. Okay, so we really haven't seen a mechanism proposed like that before, but this is what would make the most sense. Okay, so next up would be the open chain amino acid. So by moving the electrons right here onto this hydrogen, we have just opened our amino acid. We just have opened our lactam. So we should form a 6 carbons in my chain. So I have my carboxylic acid that corresponds to this part right here. So that's my carboxylic acid. I have 6 carbons, 1, 2, 3, 4, 5, 6, and then I have my NH2, which I just had leave. Okay, so that is my open chain amino acid, and then the heat component of this problem is going to have us attack another lactam molecule to form the polymer. So here I'm going to have my lactam, and that looks like this. With the hydrogen attached to my nitrogen, the electrons from this nitrogen are going to come in and attack this carbonyl, and that is facilitated by heat. So the electrons are going to come up from this double bond and attack that oxygen to form a negative charge on that oxygen. So I should form this tetrahedral intermediate, in which I have this compound. So I still have my lactam looking molecule, but instead of a carbonyl, I have my oxygen with a negative charge, and then the remainder of my compound. So I had a nitrogen attack it, and that has my 2 hydrogens. So right here, with a positive charge on that nitrogen, and then my 6 carbons. So 1, 2, 3, 4, 5, 6, and then my carboxylic acid. Okay, what would be next? The next step would be the very similar thing that happened in the previous step, in which we had my carbonyl, the electrons from my carbonyl come down, and then I had my bond between this carbon and nitrogen attack the hydrogen that was contributing to the protonated form of my positively charged molecule. So I'm going to have the electrons come down from this oxygen and attack that single bond, creating a double bond in the process, and then this nitrogen has a positive charge, so I need to protonate this nitrogen in order to make it be a stable leaving group. So using the electrons from this bond, I'm going to attack this hydrogen. Okay, and when I attack that hydrogen, I'm going to move the electrons from the single bond onto the nitrogen, forming my polymer. So this should be my final answer, where I have a carboxylic acid on this side, and then I have my 6 carbons, 1, 2, 3, 4, 5, 6, and then my nitrogen, and then that is connected to a hydrogen, and then that is connected to my carbonyl with the remainder of my compound. So 1, 2, 3, 4, 5, 6, and then I have my NH2. Okay, and then we can show this squiggly line to represent the formation of new polymers, or new monomers to contribute to my polymer.